Okay, so like yesterday, we want to be thinking about our cubic numbers that we're going to pull out of these. So 1029 is real big. It's not like we can do that in our head, really, right? You guys think that 8 is going to go into 1029? I don't think so. I don't think 8 goes into anything with a 9 at the end, right? So I'm not even going to waste my time on that. Let's see, 1029. Should we try 27?
No.
It's totally possible. If you start with smaller numbers, though, you might end up having to do it again, is the problem. So I would start with bigger numbers, like 1029, 512. Does that go in? No, you guys said which one went in? 343. Okay, 343 goes in. Great. So let's see. So this we're going to write as 6 cube root of 343 times 3. Did you guys already experiment with 192?
Yeah.
What went into 192?
64.
64? How many times? 3? Okay, sweet. So red stuff's going to come out, blue stuff's going to stay in. What's going to come out on this problem if we have the cube root of that?
7.
7, because 343 cube rooted is 7. What stays in? Yeah. And there's still a 6 chilling out here. Okay, what comes out on this one, Miss Lauritsen? 8 or 4? I know I should say an 8 because you're thinking square root, right? But cube root is 4. No, that's good. Both thoughts were good thoughts. Are these like terms?
Yes.
Yes. What kind of like terms are they? That's the way you want to think. Good. They're cube root like terms. Cube roots of 3s. Very nice. Okay, very nice. Cool. Fire. So how many cube roots of 3s do we have? 6 times 7 is 42 minus 20 minus 32. 42 minus 32 is 10 cube roots of 3. There we go. Okay. Same kind of thing on this one. There's no numbers on this one, so that should be a little simpler. I think the variables it might look harder, but it shouldn't be because you don't even need your calculator now. Z to the 11th. I should write that as Z to the 10th.
Z to the 5th.
Seems like we're forgetting that part. So, you want to be breaking it down into powers of 3, right?
Yes.
Closest power of 3 is 9.
Yes.
So I'd write this as Z to the 9th, and how many leftovers? There's 2 more Z's, right? Z squared is left over. This guy's already in terms of a power of 3, so I'm just going to leave it alone. And over here, I think that's already in terms of a power of 3, and Z squared is like stuck in there. You can't pull that out. It's not enough. There's not enough Z's to cancel anything. So this guy's like done. I don't think I can do anything with it. This one's in a power of 3 already. So what cancels and comes out? I'll use red again. The Z to the 9th cancels how many times? 3 times, because it's Z cubed, Z cubed, Z cubed. Cube root of Z cubed is Z. That happens 3 times. So Z cubed is what comes out. How many times does it cancel for this big chunk? 2. It cancels twice. So x plus 9 quantity comes out twice. And there's no leftovers except for the Z squared. This came out, and this whole chunk came out. Okay? So now if we look at this compared to this, I'm just going to write it down again, even though it's getting annoying. Oh, something comes out here, doesn't it? I forgot. That whole chunk. X plus 9 comes out twice, and you've got a cube root of Z squared left. I think I made these so that they were like terms, right? What kind of like terms are these? It's long-winded, you gotta breathe.
2Z cubed.
2 is how many of them there is?
Yeah, 2Z cubed, x plus 9 squared, and then the stuff.
The stuff, yes, okay. So they're Z cubed, x plus 9 squared, cube root of Z squared quantity. That's what they are. There's 2 of them here minus 3 of them there. 2 minus 3 is -1 of them. Oh. Z cubed x plus 9 squared cube root of z squared. That is as simple as it gets right there. Okay? So, let's look at a couple. Alright guys, so these problems all look really similar. They've got really similar numbers in them, I think. So, you can do them a few different ways. It's important to be flexible and not just like be doing this by rote. So, they all have cube roots only. That's nice. That means you can combine some things. So you could start breaking down 250 if you wanted to. 5 is 5. I mean, you can't break that down really. But you could also absorb the 2 cube roots into 1. I think we did that before. You could write this as one big cube root if you wanted to. It might help sometimes it might not. Because 5 goes into 250, doesn't it? How many times? Might be a little annoying. How many times does 5 go into 250? 50? Okay. So then cube root of 50, you want to try to simplify, but I don't know. Does 8 go into 50? Nah. 27? 64, obviously not. So I think this is as simple as it gets. You cannot simplify that anymore. So note, that was a pretty quick way to do that problem. So you want to consider it. You could do the same thing on number 4. I want to show you another way to do it too, though. Which root is really the problem that we discussed last time? The one on the top or the one on the bottom? The one on the bottom, good. You don't want to have roots on the bottom. You need to rationalize. So what clever one can you multiply by to make this root on the bottom go away? Cube root of 5. But I don't think that's going to totally make it go away. Because if you have cube root of 5 and another cube root of 5, that's only 2 5s inside. How many 5s do you need inside to cancel? 3. So I'm going to have to put this guy and another one. If I do it on the bottom to make it stay the same, I've got to make it be 1. There's my clever 1. So this is rationalizing a cube root. So if you do this, the whole point was now you have 3 5s inside the cube root. You can absorb them into 1. And the cube root of something cubed cancels. Just like when you have variables, right? You have x or something like that. And then up on top, you just kind of see what happens. I think we have the cube root of 25 times 35. I'm just going to use my calculator. What is that? 875. And then I want to play that same game that we've been playing. Which one of these cubic numbers do you guys think goes into 875? Because I think one of them does. Maybe? Okay, we can try it. No. Probably 125. Yeah. So this is 125 times 7. Cube root of 125 is 5. You've got a 7, you've got a 5. So this is the cube root of 7. Now you guys tell me, this is great math to be able to do. Sometimes you have to be able to do problems with radicals like this. What was an easier way to do this problem? The first one, right? Because we could have totally just said, this is really, since they're both cube roots, if one was a cube root, one was a square root, you couldn't do that. But since they're both cube roots, if you absorb them into 1, what's 35 over 5? Cube root of 7. Boom. Avoids all that work. This is all good work to do, so I encourage you to try it on a couple problems. But think about the different ways you can do something too, okay? So, what do you guys want to do on number 5 then?
The first way.
Yeah.
Should we try it the first way? I mean, maybe it'll work. Let's see. So if we go cube root of 250 over 2, that's what? $1.25? $2.50 cut in half. And that one we know. 5. I think that's it. So, much smarter way to do that problem too. Sometimes you have to be able to rationalize with cube roots like I did here in red though, so I'd try to practice that on at least 2 problems if you have a chance. That's enough. Okay? Alright.